Okay, grade 12. Today we're going to look at mechanics, momentum to be specific. Okay, so we're going to start with the common ground. What you already know, what we expect you to know by now. The first thing is a scalar quantity. How do we define a scalar quantity? It is a physical quantity with magnitude only. So here it has got magnitude only, right? It's a physical quantity with magnitude only. On the other hand, we also have what we refer to as a vector quantity, which is a physical quantity with magnitude and direction. So this one has got magnitude and direction, right? So these two are a part of a vector quantity. Then moving on to the next one, we also have what we refer to as velocity, which is defined as the rate of change of displacement. Velocity is defined as the rate of change of displacement. So in symbols, we can write it as v is equivalent to delta x all over delta t. The units of measurement are in meters per second. Then moving on to the next one, we also have our acceleration. So our acceleration is defined as the rate of change of velocity. Rate of change of velocity. So by formula, we're going to say delta v all over delta t, which is change in velocity over change in time. Then in terms of our units of measurement, we're going to have it as meters per second, right? Then we also have our mass there, which is defined as the amount of matter in an object. Then we also worked on inertia in grade 11, which is defined as the resistance of an object to any change in its state of motion. Then now moving on to our topic of the day, which is momentum. Okay, so in terms of momentum, what do we mean by momentum? So momentum, we can break it down to something like this is mass which is in motion, right? So we can say mass in motion, right? For us to have momentum, this mass or this object should be in motion, right? So now if you can check here, it means here for motion to be there, it means now there is a velocity. The object is in motion, it is moving. So here we're going to have our velocity. Then the mass here is the amount of matter within that object, right? So now going on or moving on to the definition that we need according to our exam guideline, is defined. Momentum is defined as the linear momentum is the product, right, of an object's mass and its velocity, right? So here by product, we know it means we are multiplying these two, right? The mass of an object and its velocity. Therefore, now if we are to look at this now, you should also take note of that this is now velocity is a vector quantity. Hence we say it's a vector quantity. It has got both magnitude and direction. Then in symbols, this can be deduced as P is equivalent to mv, where P is the one that represents your momentum, right? So P represents momentum, and then the V is the velocity, and then we also have our M there, which is our mass, right? So in terms of this, if you can break it down further, you can say that your velocity should be, the units of measurement there should be in meters per second, right? Then the mass here is in kgs, right? So if we were to deduce the units of measurement there, we're going to say P is equivalent to M, right? Multiplied by V, which is your velocity, right? So if I'm to bring down this mass here, the units of measurement for mass is in kgs, and then multiplied by this velocity, which are the units of measurement are in meters per second, right? So if we were to combine these two, we're going to have the units of measurement as kg meters per second, like that, right? So also we can also say Newton multiplied by seconds, like that. Okay, so we also need to take note of the direction. Since momentum is a vector quantity, here we're multiplying it mass by a velocity, product of mass and its velocity. So remember, velocity is a vector quantity, so it is important for us to always specify in which direction our momentum is going to be, right? So we are going to choose direction either, let's say for example, to the right as being positive. It means if the velocity of the object is moving towards the left, is going to be in negative, right? So moving on to what can be deduced from P is equivalent to mv. What is it that we can learn from P is equivalent to mv, right? So according to this, we can see that P is directly proportional to V, right? So here in terms of this, we are going to say whenever we're having a constant mass, whenever we're having a constant mass, right? So what does that mean? If V doubles here, we're going to say if V if v is to double, okay, if let me just erase that one. If v, which is your velocity, it doubles, then what is going to happen to our momentum p, right? So if v doubles, what does that mean? It means also p it doubles, right? So doubles like that, right? So it means whenever this is multiplied by 2, this other one is also going to what? To double like that, right? Then also the other relationship that we can deduce here is the relationship between P and M, right? So P also is directly proportional to mass, right? At a constant velocity. Here we are going to have a constant velocity, right? So now what happens here if M doubles, right? So if M doubles, what we are going to have here, M doubles, what we are going to have here is that P is also going to double. So P also doubles like that. So this is what you are going to have there. So always take note, whenever you increase the mass, momentum also is going to increase, right? So P is directly proportional to velocity whenever the M is constant, and then P is also directly proportional to M whenever the velocity is constant. What we mean by that is that whenever we double the mass of an object, P is also, or momentum is going to to double. So having said that, now we can proceed to also take note of the other thing you need to take note of is that momentum is in the direction of velocity. So it means that the direction of velocity is, momentum is always going to be in the direction of what? Of your velocity. Then as an example, we're going to go example number 1. So here the example reads here, a ball of mass is 0.05 kg. So we're having a mass of 0.05 kg is kicked to the right. Take note of the direction. So it's going to the right by a player. Then the ball leaves the player's foot at a velocity of 40 meters per second, right? So this is the velocity that you are given here. Then we are asked to calculate the momentum of the ball as soon as it leaves the player's foot, right? So take note here, I usually go through this in such a way that it makes it easier for us. So we need to break down this into our data, right? So the formula for momentum, we already know our formula. P is equivalent to mv. Remember, this is going to be given on your data sheet, so it's a matter of like copying it from your data sheet. Then here in terms of P, here what do we know? We're going to say P is our momentum, so we know by formula this is equivalent, P is equivalent to mv, right? So and then on the side, maybe I can just like put the units of measurements there. We know it's kg meters per second, and then the mass of an object should always be in kilograms. Then also we're having our velocity, which is in meters per second here. So I'm going to include my direction. So here I'm told the ball is kicked to the right, and then here also I'm going to choose the direction of motion to the right as being what? Positive, right? So now according to this, what mass do we have there? We're given a mass of 0.05 kgs and then a velocity of 40 meters per second, right? So now what are we asked to calculate? We're asked to calculate momentum, right? So already I do believe we now know what we are supposed to do. Then we're going to proceed and say, now substitute with the mass there, which is 0.05 multiplied by 40. Okay, so now let's grab our calculators quickly and do the math there. So what we are going to get, 0.05 multiplied by 40, 0.05 multiplied by 40, I'm getting a value of what? Of 2. So my answer is going to be 2 kg meters per second, right? So remember, we said this is a vector quantity. So remember also what we said in terms of the direction, right? So we say it is a vector quantity. Direction is important in every calculation. So also this is going to take the direction of the what is in the direction. Momentum is always going to be in the direction of the what? Of the velocity there. So it means here I'm going to say my final answer is 2 kg meters per second. To which direction? We're already told this ball was going to what? To the right. So it will take the direction of the what? Of the velocity. So I'm going to say to the right like that. So that's how we interpret or answer such a question. Now moving on to the next example, we also have a question there that says calculate the momentum again of a bullet with a mass of 40 grams, right? Fired at a velocity of 400 meters per second west. So our direction is west, right? So we know the west direction is going to go in this direction, and then also I'm going to take that direction of motion as being positive, so I'm indicating west as being what? Positive, right? So we now know P by formula is equivalent to mv, and then this mass here should always be in kilograms, right? Take note of this. So here, what does that mean? We are supposed to convert that 40 grams to kilograms. Then the velocity there has already been given as 400 meters per second, right? So I'm going to say 400 there. So now what do we have there? We are having a 40 grams, right? So for us to convert this one, we're going to say 40 divided by 1,000 for us to convert to what? To a kilogram. So if I say 40 divided by 1,000, I'm getting a value of 0.04. So it's now in kilograms, which is 0.04 k, which is like that. Then now to proceed there, I'm going to say P is equivalent to, I'm going to substitute with the mass there, 0.04, and then multiplied by my velocity, which is 400, like that, right? So if we're to punch our calculators there, multiplied by 400, I'm getting a value of what? 16. Okay, so it's going to be 16. Remember, the units of measurements is kg meters per second, right? And then also know that this is a vector quantity, and where was it going? The direction of the velocity, or the velocity is heading, the object is heading towards what? The west. So I'm going to say here towards the west, like that. So this is how we go about it. Also take note, right? It's important for you to start with what? With the formula. But I opt, if you are to use this table, it makes it easier for us to interpret what the data that has been given. And then now moving on to our collisions there. So what are we talking about whenever we're talking about a collision, right? So usually we're going to say it's an isolated event where two or more objects exert a force on one another over a period of time, right? So it means now for objects to collide, they must be in contact, right? So over a certain period of what? Of time, right? It can be a shorter period of time, it can be a longer period of time, right? So now we're saying when collisions occur, the velocity of object, it changes, right? So an object is either going to slow down, or the velocity is going to increase. For example, if we're having a ball that is stationary, right? So if we are to kick it, it means its velocity is going to increase. But if this ball is going to hit the wall again, what is going to happen to its velocity? This velocity is going to decrease, right? So now we're saying when collisions occur, the velocity of objects, it changes, right? So when velocity changes, it's either an increase or a decrease. Momentum also changes, right? So remember, by the way, your velocity, your momentum, we say according to the formula, P is equivalent to mv, right? So it means whenever we are to change this velocity, the final answer of momentum is going to change, right? So remember, when we talked about, when we said P is directly proportional to m, where v is constant. Also we said when P is directly proportional to V whenever m is constant, right? So at a constant velocity, at a constant mass there, what happens there if we are to double the velocity, right? If this velocity doubles, right, it means also our momentum is going to double there, like that. Okay, so now we're having a term that says here a change in momentum, right? So it means now, why is there change in momentum? It is because there have been differences in terms of what? Of the velocity. It means either there was an increase in velocity or a decrease in velocity. Okay, now to deduce this, now we're going to say change in momentum. By formula, we write change as delta P, right? So delta P is equivalent to delta P is equivalent to the change in velocity or mass. So it's going to be m delta V, right? Like that. So by formula, this is how we write our momentum, right? So in terms of this, I can also maybe start by saying, right, for it to be a change, right, there's been a change, not in velocity, right? So I'm going to say here as a formula, either I can start here and say delta P, which is a change in momentum. So since we're saying there are differences in two momentums, right, that is the initial momentum and the final momentum. So what you're going to have here, I can just say P final minus P initial, right? So which is P final momentum minus my P initial, which is the initial momentum, right? So now to break it down further, I can proceed and say delta P is equivalent to, delta P is equivalent to, now we know, remember we said our P is equivalent to mv, right? So now in terms of this, now we're saying the velocity is the one that is what is changing, right? If we're having a delta V there, so it means here there was the initial and the final velocity, right? So that change is denounced by Vi minus Vf, right? So I'm going to say here mv final minus my mv initial, right? So then to proceed there, I can also just like figure this out as delta P is equivalent to m delta v, right? So here in terms of this, you can see that the velocity is the one that has been changing, right? So to make it easier, to make it make sense, let's just like quickly dive into a question and work it out, right? So we're having here an example that says here a ball of mass 200 grams, right? So take note of this data there that you're given is in grams, and we know the units of measurement should be in kgs for this mass, right? Is thrown against a wall at a velocity of 12 meters per second, right? So this is the velocity. Then after the ball collides with the wall, it then moves in the opposite direction at 10 meters per second, right? So for it to be easy, I'm going to draw a scenario. Let's assume this is our wall, right? So now this ball is first thrown in this direction, right, towards the wall, right? So this is my ball towards the wall there. So they are telling us the initial velocity was 12 meters per second, right? So heading towards the wall, right? Then after that, now this is the second part, right? So this is going to be the first, and then let me just like indicate there, this is scenario number 1, right? And then the second part there, it reads the second part there, after the ball collides with the wall, it then moves in the opposite direction, right? So it means now it's heading in the opposite direction. It means it's moving backwards. So now this is our ball. Now after colliding with what? With the wall, it's now moving in the opposite direction, and we are told at a velocity of what? Of 10 meters per second, right? So this is what we are having there, 10 meters per second, right? Then now to proceed with the question now says here, calculate the momentum of the ball before collision with the wall. Before, right? So here before, what does that indicate? It says it's same as like they are telling us initial momentum, right? So it's more of them referring to what? To initial momentum, right? So it means here we're having initial momentum. Before, I'm going to say initial, right? So this is our initial momentum, right? So how do you calculate momentum here? Remember, I'm going to say your P is equivalent to mv. So I'm going to use this space here. Remember, P is equivalent to mv, right? So here I'm going to say pi, right? So to be specific here, I'm going to say pi. The I is for initial there, is equivalent to m, then I'm going to say v I again. So this is the initial velocity of the what? Of the ball, right? So now to proceed there, I'm going to say the mass of the object there. Let's go back there. At the top, we're given the mass of the object is in 200 grams. Remember, we said the units of measurement is in kgs, therefore we're supposed to convert that one in grams. Yes, you remembered it. So we're supposed to say 200 divided by 1,000, like that, right? So if we say 200 divided by 1,000, what are we going to get, so that we can get our units in kilograms? So our answer there is going to be 0.2 kgs, right? So this is 0.2 kg, kilograms there. So the units of measurement there are in kgs, and then here we're having our units of measurement as in meters per second, right? So now let's go back to our scenario there. We're told it moves at 12 meters per second, right? So 12 meters per second, right? So this is going to be 12 meters per second. Then the final there, I'm going to choose this direction as being positive. It means heading towards the wall is positive, right? Like that. So what does that mean? It means this 12 here is going to be a positive value there. Then now if I'm to plug in the values there, I'm going to say 0.2, 0.2, then we multiply by the velocity. Take note, this is going to be positive because we chose heading towards the wall as being positive. So I'm going to say multiplied by 12 there. So it means my answer there is going to be a value of what? 2.4. So I'm going to have 2.4, right? Take note of the units of measurement again, kg, meters per second, right? Towards the wall, right? So I can say towards the wall, towards the wall, right, or to the right, okay, towards the wall, like that. So now the second question is there, the momentum of the ball after colliding, right, after colliding, right. So what does that mean? It's after. It means this one I can consider as the final momentum, right? So the final momentum, let me just like make use of a different color there. So the same formulas we're going to apply there. So I'm going to say P final is equivalent to mv. What is changing there is our velocity, right, vf, right. Then I'm going to proceed there. Also take note, I'm going to take the same value of the mass there because it remains constant. The mass of the ball remains what? Constant. So 0,2. So what does that mean? Since we chose to the right as being positive, what does that mean? This object now is moving in the opposite direction. What does that mean? It means now we are going to use a negative value because it's now moving in the opposite direction, right? So I'm going to say multiplied by negative 10 there, right? So it means now if I can multiply that one there, 10 multiplied by 0,2, we're going to get a value of what? Of 2, right? So I'm going to say 2, okay? So it's supposed to be a negative 2 kg meters per second, right? As my final answer there, therefore I can say this is 2 kg meters per second, where away from the wall, or moving away from the wall, like that, okay. So that's what we are having there. That is our answer. Then moving on to the next part there, it says calculate the change in momentum, right? So we're asked to calculate the change in momentum, right? So how do you calculate the change in momentum? So allow me to scroll down there. So remember we said our P is equivalent to m delta v, which is the change in velocity, or we can say P final delta P is equivalent to P final minus my P initial, right? So let's start with this one there, right? So this is equivalent to my P final. Let's look at the P final there. So the final momentum was this answer, which is a negative 2. So I'm going to take it as it is and say negative 2. Then according to this formula, I'm supposed to subtract the minus, then I'm going to put a bracket there. So minus what, right? So P initial, we got an answer of what? P initial, it was 2,4, right? So I'm going to say 2,4, right, minus 2,4, right? So if we were to do our math there, we're going to get a negative 2 minus 2,4, we're going to get a value of what? 4,4, right? So negative 4,4, negative 4,4, I'm going to say kg meters per second. Remember, this is a vector quantity, so it must have a direction there, right? So what are we going to have there? So I'm going to say towards what? Away from the wall, like that. So that's what we are having there, right? Then now to move on to the next one, or if we wanted to manipulate this one, we're going to proceed there. Remember your delta P there, not just a P. Delta P is equivalent to m delta V, right? So I'm going to proceed and say, therefore, this is the mass of the object. The mass of the object remained constant throughout. Remember, we said it's 0,2 there. We're given a value of what? 0,2. Therefore, I'm going to say 0,2, right, multiplied by what? By our velocity. Or to make it easy, let me just like break it further here so that it's actually visible. If I'm going to proceed and say m, right, so I'm going to say a bracket there. What is changing is our velocity, right? So I can just say vf minus my vi there, right? Then I'm going to proceed and say the mass of the object there that we're having was 0,2. Then I'm going to say the final velocity. The final velocity, if we look here, we said is 10 and negative 10, right? So it's going to be negative 10, then minus bracket there, that's a positive, right? Positive 12, right? So if I can solve the inner bracket there, so the inner bracket, let me just use square brackets there. So if I start with the inner bracket there, what am I going to get? So I'm going to say 0,2, then bracket there is going to be minus 10 minus multiplied by a positive, you're going to get a what? A negative. So it's going to be minus 10 minus 12, right? So it means now I'm going to have a negative 22, right? So if I multiply that one, negative 22 multiplied by 0,2, I'm going to get an answer of 4,4, right? So our final answer there is 4,4. It's a negative 4,4 kg meters per second, right? So that's our final answer there, right? So that's how we go about that one. Then the last question says represent all of the above as a vector diagram, right? So there are two ways to go about this one there. So in terms of this, we can say we start with the initial velocity. So I'm going to start by drawing maybe something like this to the right there. So it was moving at a velocity of 4 there. It was moving at a velocity of 4 meters at a velocity of 12 meters per second. So I'm going to say 12 meters per second there. So my value there, what did I get for 12 for the first one? Oh, I got a value of 2,4. Sorry about that one. So there I'm supposed to write 2,4. Let me just erase quickly. So at the top there we're going to have a value of 2,4. So I'm going to say 2,4 kg meters per second, right? Then the other one now was heading towards the left, and then what did we get there? We got a value of what? I got a value of what? 2 kg meters per second, right? So there I'm going to say 2 kg, 2 kilograms meters per second, right? So you can take note of, like, the second part there is heading towards the left, right? So the other one was heading towards the what? The right. And then the values again, you can see my line is longer. The one for 2.4 is longer than the one for what? 2 kgs. Then after that, now 2 kgs meters per second. Right now, after that, now we can draw the final one, which is our delta p, the final change in momentum, right? So I'm going to have something like that there. Then I'm going to say this is my change in momentum, and then we are having a value of what? Of 4,4 kg meters per second, right? So the first one there is p initial, and then this one is p final, right? So that's how you can go about it. Or you can opt to go this route and say this is your p initial, so this is p initial. According to our calculations, it was 2,4 kgs meters per second, and then the other one is heading towards the left, and it's a value of what? 2 kg meters per second, and then the change in momentum, the delta p. So this one was what? Our p final, and then the change in delta p, we are going to throw an arrow because the answer is negative, so it's heading towards the left, and then the final answer is same as 4,4 kg meters per second, like that. Okay, so now with that being said, hope you enjoyed this. So now this is the follow-up activity that I want you to work on. It says a plate of mass 0,02 kg is fired horizontally into a suspended stationary wooden block of mass 1,95 kg with a velocity of 20 meters per second. Ignore the effects of air resistance. Then the first question asks you to define the term momentum as applied in what? In physics, right? So we're supposed to define it in what? In waves, right? It's 2 marks there. Then after that, calculate the momentum of the bullet just before impact, right? So this is the follow-up activity. Please, on the comment section, give me the answers. Thank you for watching.